background. Let's do some problem strings. So, can I use problem strings to introduce or remind about something that kids might have maybe percolated before? So can I introduce something or maybe remind about something? If I was going to be an Algebra 1 teacher, I might be introducing this. If I was an Algebra 2 teacher, I might be reminding kids. Here is a problem string to introduce or maybe just sort of remind stuff that kids might have done. I might say to kids, hey guys, you've seen this before, -2, 5. How might a mathematician represent that in some other ways? So I'm just like pulling on kids' prior knowledge. What might a mathematician do with -2, 5? What might kids say? They'll know. They might have a table. So they might sit over and they're, okay, an X and a Y, they have a -2, they have a 5. They might have a graph, right? So I have a graph over here. Let's see if I can do this for -2 and 5. Okay, -2, it's over there. Anything else?
Interval of numbers.
Ah, yes, so that's not the notation I mean today, and I'm just going to tell kids. I could be talking about interval notation, that's more usually higher than that, and so I would say, not that. Cool. Anything else you might think of, and maybe in Algebra 2 class, kids might go, wasn't there that F thing? They might be careful about F thing. wasn't there that F? I would say, oh yeah, now if I'm in Algebra 1 class, I would go, hey, there's another way that mathematicians represent this, and they might represent that by F at -2, some function that I'm defining. When I stick -2 in, I get out 5. That's just a thing, and I'm going to directly tell kids. Weird, we came up with this notation, who knows? If it's Algebra 2, I'm reminding them. If it's Algebra 1, I'm like telling them. Yeah, this is a way that we can sort of talk about a point on a function. Maybe it's the only point on a function. Cool, the next problem in our string. So the next problem in our string, I might say to kids, so what if I told you f of 2, that same function, because it's still f, I'm naming it f. That f of 2 is -3. So, give me all the other representations. What are kids going to do? They're going to say, all right, if f of 2 is -3, then I might look over here at 2, and I might go down to -3. I'm not taking very much time to do any of this. About as much time as I'm doing here. Anything else? Oh, no, I'm missing one. Yeah, the ordered pair. So, oh, Pam. So how about if I do it right? What should that be? 2 -3, right? A better presentation would have been to do it wrong and make you go, wait. Because kids will probably at this point go, oh, so is it the same? Function notation gets weird, right? Where does it fit? Maybe, I don't know, maybe not at this point yet. So then I might say, let's see if we can solidify this. You guys did that really well, you know what it means now. So if you know what it means, then f of 5 is -9. I let this one go even faster. Where would f of 5 be? -9. Now here, weird, that almost looks like those are linear. Strange. So let's see, what is this one? 5, -9. And then I'll put it in the table, -9. I write it as an ordered pair. And then I move on. And I say, so if I have this same function, and I tell you that that same function at 1, oh, actually I don't know what it is. I wonder what it is at 1. Huh. That's the next problem in our string. Go ahead. What is f at 1? Could students do that at this point? How might students reason about f at 1 right now?
Connect the dots.
They might connect the dots. So they might walk up to the board and they go, well, if it's linear, because I think it might be. Did you notice that I sort of prompted that a little bit? Weird, might be linear, weird. And they're like, oh, sure enough, I think it might be linear. Well, if it is, then they could come over and they could draw something, and I could try. I wish I actually had a grid on. Note to self, next time I'll turn a grid on. I'm going to, like, change colors. Can you see the yellow? I'm going to try to see if I can, oh, how did I do?
Good.
Ish. A little bump in there. So if that's f, could I use the graph to go over to 1, and say, so at 1, where's the graph? Oh, it looks like it's like right there. So what's your guess? Looks like it might be -1. And then I'm going to pause. And I'm going to wonder if any students are like, well, if it's linear, we could do something about that. If it's linear, can you do something about that? Like, find the equation of that line? Okay, find it. Go ahead. I don't know what it is. You guys are all staring at me. Wait, we have to work? Yes. So, actually find the equation of that line. You have some points up there. Choose your favorite ones. Cute group. Totally disappeared. I'm a loser. What are you thinking? How'd you do that? Who just said negative touch this one? Was that you? Okay, Nicole's friend. How'd you do that?
I found that it's going.
Did you use the line that I drew?
Yes, I did.
Okay, so you could use the line that I drew and hope that I drew it well. Did anybody use the points?
Yes.
Yeah.
Okay, and did you also get negative 2x plus 1?
Mm-hmm.
Okay, so I'm just going to sort of hold that over here. We think it might be negative 2x plus 1. Maybe we could, as a teacher, can I not take the time right now to actually like use a couple points and, oh, that's how you, those points, good. Oh, great, maybe it is negative 2x. Sweet, you read it off, it worked, good, moving on. I might continue to represent that in all the other ways. So I might say, what does that look like? Is that 1, negative 1? And we already graphed it on the table, and I would add it to, or in the graph, I would add it to my table here, though I'm a bad presenter, and I didn't, I'm being techie for a second. I'm going to shrink my table so that I can add, yeah, it's really not cool. I should have done it from the beginning. 1, negative 1. Okay, so the next problem on our string, good thinking everybody, nicely done. What if I said that it's still the same function, but I don't know the x value? F at something is 0. Can you find that? What does that even mean? Now you know, because you guys own function notation, but your students don't, right? So I might do some work with them to go, what does it mean in the ordered pair? Where does the 0 go? Oh, it goes there. Okay, where's it go on the table? It goes there. So what are we looking for? Oh, we're looking for the x value where the y value is 0. Can you guys find that? Okay, what is it? Everybody yelled out? Looks like it's 1. Could I then, I'm not going to do it right now, but could I actually use this equation that we think it is and say, oh, so is it 1? Like, could we use this? What if that's equal to 0? So negative 2x equals negative 1. I think x might be 1/2. Good try. So that's a reason to actually sort of know the function rule. So it's not f at 1, it's f at 1/2. Cool. The last problem on our problem string, you guys are doing a great job. All I want you to do now is tell me, what's f at any x value? Okay, so like this is the coolest problem string I have ever written. Because at this point, what is f of x? It's negative 2x plus 1. Now you're math teachers, so you're like, okay, is that cool? Yes, that is really cool. Because what we just did was build function notation in a way that because kids are doing the relationships and connections in their own head, I submit to you they now own function notation better than ever when we just said, here's what it means, whatever that traditional stuff that we used to do. This is like my favorite problem string I've written lately, like ever. Would have been better with a grid on the screen. Put a grid on the screen when you do this, which is easy, right? Just like project Desmos or project a graphing calculator, just project the grid and then draw on the grid. I wouldn't have been doing anything else like putting points in Desmos or anything like that. I still would have been drawing on there. What do you think? Can you see how what I did was a series of problems that every time we had a little bit of conversation where I'm sort of nudging some ideas. Gee, those look a little linear. Weird. I'm nudging a few ideas as I go. And I'm asking kids to then apply, maybe in a different way than they would have been able to. And a kid who's never heard about function notation, do I think they own it at this point? Nah, I'm not suggesting they own it. But do they have a pretty good sense of it? Would I want to do another problem string to follow this up, or a truly problematic situation, a rich task, to make sure that they really get, of course, they would want to do more work.